can bring that to me, Kariah. Thank you, dear. We're just started notes. Okay, we are going to apply some exponent rules, a little more challenging than in Chapter 5. Let's go over some quick vocab. I think everybody has it. We just shouted out some of these answers. 6 to the 3/4. What's the base? Good. What's the power? Be careful. Close. Too much. You gave me too much. What's the power? What's the root? 4. Why is that? Because the denominator denotes the root, and the exponent fraction in the fraction gives you the power. Can you switch from radical form to exponent form, and from exponent form back to radical form? That's the question. Two to the 3/2 power. What do y'all think? What would that be as a radical? 2 to the 3rd, good. And why did you say just regular radical, Wes? Yeah, it's a square root. We don't have to put the little 2 in the radical position. Very nice, good. Question, Harrison? Four to the negative 5/2. You should deal with the negative first, in my opinion. It's not the only way to do it, but what is the negative telling you about 4? It's living upstairs in the numerator, and where should it be moving? Downstairs to the denominator. Once you do that, that takes the negative off the exponent. Write this as a radical for me, Keandre. Yeah, regular square root. If we're going to simplify this, we really have 5 fours. So we have 4 squared times 4 squared times 4, all under square roots. Do you know why I took them 2 at a time? Does anybody know? Yeah, it makes it easier, but why didn't I take them 3 at a time? Because that would have made it easier too. Also, what am I trying to make the power match? The what? If you add the exponents to 5, that has to happen. Yes, Ashby's right. You have to make the exponents equal to 5. Does anybody know why I took them, though, 2 at a time and made a power of 2? Go ahead. Because it's a square root, that tells you if you can get anything to the power of 2, it will quickly cancel with anything with the square root. What if it was a cube root? What would your goal be for the exponent? 3. Good. So all of these that have an exact match with the root and the power, they're going to simplify. And something happened here that doesn't always happen. What is the square root of 4? 2. Usually you have to rationalize the denominator, but in this particular one, you did not. It would. And then you'd hit math fraction enter. You'd give you an ugly decimal first, Harrison, and then it would tell you. So let's talk about it if it were 1 over x to the 5/2. Let's do the exact same problem, but let's make the variable a base. So we started with x to the negative 5/2. You put it in the denominator, then we're going to take the same strategy. Because we know 2 is the root, we can square root the x squared, we can square root the x squared, and that leaves us with the square root of x. Because, as Ashby said, the exponents have to add up to 5. So we have 2 and 2 and 1, and that would add up to the numerator 5. What's going to simplify first, Erica, in this little bottom part? Okay, so I'm going to end up with 1 over x times x, which is x squared, times the square root of x. Does anybody know what's wrong with the denominator? It's not rational, is it? So we have to it's irrational, we have to rationalize it. So we end up with the square root of x over x squared times the square root of x squared. What is the square root of x squared? What's going to happen right here, Hunter, with the square root and the square? Yeah, they are. So that means we have the square root of x over an x squared times an x to the first is an x cubed. There's a temptation here you cannot fall for. Can you cancel that x with one of those x's? I heard no's on both sides. Now the question is why? Right, it's not actually an x, it's the square root of x, which makes them unlike terms. Good job. All right, let's try another number one. How would you write this from exponent form to radical form? What would you all do? Why'd you say 1 over? But is the exponent negative? Do you see what Wes did? Common misconception, yeah. What happens when you do the first power of negative 216 to the third root? Somebody check that for us and tell us what the negative answer is. And then let's talk about why. I don't know what it is. I mean, I have it in my notes over here somewhere. How do you find the cube root? Math and then what? Straight down 4. What'd you get, Selena? Now, why does that work? Because we could rewrite this as negative 6 to the third, could we not? If I wrote negative 216 as negative 6 to the third, what's going to cancel out there, Spinda? The root that is 3, good, and the power that's 3. Riley, will you put it on my desk so I can grade it and put it in your folder? Thank you. If you put that in your calculator, everybody do this. Negative 216, hit the caret key, hit green. What does green say? Alpha y equals. Choose number 1 fraction and put in 1, arrow down, put in 3. Tell me if you can get it to look like that with the little power fraction. Okay, then press enter. What does it say? So do you have to go to math and do that? No. No, no, no. Find the nth root of a. How would you write that as a math problem instead of a word problem? Find the nth root of a. Pick up here, Riley, and I'll copy what we've done already for you. Find the nth root. Go ahead, Harrison. N would be your index number in the radical, good, and your a would be under the radical. So then if I tell you n is 4, and a is 81. How would you proceed? What would you do, Wes? Replace them. All right, so n is going to be 4. A is going to be 81. How would you attack this with your calculator? Is there an nth root button? I think there is, but I think you have to put the 4 in first. So maybe hit 4 and then go to math. Is there one that has like an X in the root position? 5? Okay, so put your 4 in, hit math number 5, and then does it let you put the 81 under? Okay. You could also write it in exponent form, right? It was the power of 1. What did y'all get for an answer? Did anybody do it this way? Somebody test this way. (81 to the power of 1/4). It's 3. So could you do it either way? Sure. (16 to the 3/2). You could do the square root of 16 to the 3rd, or you could do square root of 16/3. I would like this side of the room over here to do the right side way. I want this side of the room to do the left side way, and tell me what your answers are. This side's doing the left way, this side's doing the right way. You there, Keandre? Okay, what'd you get for the left one? What did you get? 64. I thought you said 4. I knew that was too small. What did this side get? So what then rule would you make about exponents and radicals? Does order matter? Does it matter if you do the exponent first and then the root, or the root first and then the exponent? Doesn't. It'll give you the same answer either way. So if you like to do the root first, do the root first, then the exponent. If you like to do the exponent first, do the exponent first, then take the square root. You guys just tested that theory, and it gave you the same answer either way. I have a balance scale. I have 32 to the negative 3/5 in this side of the balance scale. I want you to create something that will make this fulcrum completely balanced, and we can lay it in that tray. Do you have any idea what we should do to try to make that happen? Any suggestions? First, we got to put it where? It's living upstairs. Where is it supposed to live? Kelsey, you want to do the root first or the exponent first, or do you care? Okay. I think I will do the root first. So I'm going to write it like this: the 5th root of 32. Somebody tell me what the 5th root of 32 is. 2. Good. And then 2 times 2 times 2 is 2 times 2 is 4 times 2 is 8. That's in the denominator. So to make 32 to the negative 3/5, which looks hideous, all you would have to do is lay 1/8 of something in this side of the tray. And what will we say they were? Balanced or equal. They're equivalent expressions or showings of the same exact quantity. Pre-algebra, you did this. How did you solve it? Okay. 2x equals 4. What next, Selena? Divide by 2. X is 2. Is that a difficult problem to solve? No. I mean, like, you look at that and you're like, why can't I have an entire EOC made of that, right? This sits on one side of the balance scale. The 7 sits on the other. You got to figure out what to put in for x to make the fulcrum be equivalent. It's almost identical to what you're thinking when you do this. What do you have to do first when I ask you to solve this little guy? Careful. Good. Divide by 4. What did that give you? X to the 5th equals what? Now, how are you going to undo a 5th power? Savannah, what do you think? You want to phone a friend? You want to? All right, somebody who knows, raise their hand so she can phone a friend. 3 people? 4? Did you pick one? Wesley. 5th root. To be multiply, Savannah, it'd have to be a division problem to undo it with that. X to the fifth can be undone with the fifth root, and the fifth root is 2. So if I put a 2 in for x, that would make that side balance with the 128. So the solving questions on these are not much more difficult than what you did much earlier in your mathematical career. Now, this is new. What I'm giving you to do today is not so new. We are going to go back to section 5.1 one more time and work on it. Yes, Harrison?